Hi everyone, I'm Albert AI, and today I'm going to be talking about how nodes and neural networks work. A node is a computational unit that has one or more weighted input connections, a transfer function that combines the inputs in some way, and an output connection. The weighted input connections represent the strength of the connection between the node and each of its inputs. The transfer function determines how the node combines its inputs to produce an output. A neural network is a network of nodes that are connected together. The nodes in a neural network are arranged in layers. The input layer is the first layer of nodes in a neural network. The output layer is the last layer of nodes in a neural network. The hidden layers are the layers of nodes in between the input layer and the output layer. The nodes in a neural network are connected to each other by weighted connections. The weights of the connections represent the strength of the connection between the nodes. The weights of the connections are learned by the neural network during the training process. The transfer function of a node determines how the node combines its inputs to produce an output. There are many different types of transfer functions that can be used in neural networks. Some common transfer functions include the sigmoid function, the tan function, and the ReLU function. Neural networks are used in a wide variety of applications, including image recognition, natural language processing, and machine translation. Neural networks are able to learn from data and make predictions. This makes them very powerful tools for solving complex problems. There are many different types of neural networks, but they can be broadly classified into two categories: feed-forward neural networks and recurrent neural networks. Feed-forward neural networks are the simplest type of neural network. They take in inputs, perform a series of computations, and then output a prediction. Feed-forward neural networks are often used for classification tasks, such as recognizing images or classifying text. Recurrent neural networks are more complex than feed-forward neural networks. They can remember information from previous inputs, which allows them to learn long-term dependencies. Recurrent neural networks are often used for natural language processing tasks, such as machine translation or text summarization. Beyond the two most common examples, there are some other types of neural networks. These include perceptron. The perceptron is the simplest type of neural network. It has one input and one output. The perceptron can be used to classify data into two classes. Multilayer perceptron. The multilayer perceptron is a more complex type of neural network. It has multiple layers of nodes, and each layer can have multiple nodes. The multilayer perceptron can be used to classify data into more than two classes. Convolutional neural network. The convolutional neural network is a type of neural network that is specialized for processing images. Convolutional neural networks are often used for image classification and object detection. Training neural networks is a complex task. There are many challenges that can make it difficult to train a neural network to perform well. One of the biggest challenges is choosing the right architecture for the neural network. The architecture of a neural network determines how the network is structured and how the data flows through the network. There are many different architectures that can be used, and it can be difficult to choose the right one for a particular task. Another challenge is choosing the right hyperparameters for the neural network. The hyperparameters of a neural network are the settings that control how the network is trained. There are many different hyperparameters that can be tuned, and it can be difficult to find the right combination of hyperparameters that will allow the network to learn effectively. Data quality is also a major challenge in training neural networks. The data that is used to train a neural network must be high quality and representative of the data that the network will be used to predict. If the data is not of high quality, the neural network will not be able to learn effectively. Overfitting is another challenge that can occur when training neural networks. Overfitting occurs when the neural network learns the training data too well and is unable to generalize to new data. Overfitting can be prevented by using regularization techniques such as dropout. Training time is another challenge that can occur when training neural networks. Neural networks can take a long time to train, especially if the network is large or the data is complex. This can be a challenge for applications where the neural network needs to be trained quickly. Hyperparameters are the settings that control how a neural network is trained. Some of the most important hyperparameters to consider include learning rate. The learning rate determines how quickly the neural network learns. A high learning rate will cause the network to learn quickly, but it may also cause the network to overfit. A low learning rate will cause the network to learn slowly, but it may be less likely to overfit. Number of epochs. The number of epochs is the number of times the neural network will see the training data. A larger number of epochs will allow the network to learn more, but it will also take longer to train. Batch size. The batch size is the number of data points that the neural network will see at a time. A larger batch size will allow the network to learn more efficiently, but it will also require more memory. Regularization. Regularization is a technique that can be used to prevent overfitting. There are many different regularization techniques that can be used, such as dropout and L2 regularization. The best way to choose the right hyperparameters is to experiment. Try different combinations of hyperparameters and see what works best for your particular dataset and task. There are many different types of neural networks, each with its own advantages and disadvantages. Here are some of the advantages and disadvantages associated with different types of neural networks. Perceptron. The perceptron is the simplest type of neural network. It has one input and one output. The perceptron can be used to classify data into two classes. The perceptron is a simple and easy to understand type of neural network. It is also relatively fast to train. The perceptron is a simple type of neural network, and it is not as powerful as more complex neural networks. It can also be difficult to train the perceptron on large datasets. Multilayer perceptron. The multilayer perceptron is more powerful than the perceptron and can be used to solve more complex problems. It is also more flexible and can be adapted to different tasks. The multilayer perceptron is more powerful than the perceptron and can be used to solve more complex problems. It is also more flexible and can be adapted to different tasks. The multilayer perceptron is more complex than the perceptron, and it can be more difficult to train. It can also be more prone to overfitting. Convolutional neural network. The convolutional neural network is a type of neural network that is specialized for processing images. Convolutional neural networks are often used for image classification and object detection. The convolutional neural network is very good at processing images. It is able to learn the spatial relationships between pixels in an image, which makes it very good at image classification and object detection. The convolutional neural network is specialized for processing images, and it can be difficult to use for other tasks. It can also be more computationally expensive than other types of neural networks. Recurrent neural network. The recurrent neural network is a type of neural network that is specialized for processing sequential data. Recurrent neural networks are often used for natural language processing tasks, such as machine translation and text summarization. The recurrent neural network is very good at processing sequential data. It is able to learn the temporal relationships between data points, which makes it very good at natural language processing tasks. The recurrent neural network is specialized for processing sequential data, and it can be difficult to use for other tasks. It can also be more prone to vanishing gradients, which can make it difficult to train. Neural networks are powerful tools that can be used to solve a wide variety of problems. However, it can be difficult to interpret the results of neural networks. This is because neural networks are often black boxes, meaning that it is not always clear how they make their predictions. There are a few things that you can do to interpret the results of neural networks. Look at the features that the neural network uses to make its predictions. Neural networks often learn to use features that are not directly observable. By looking at the features that the neural network uses, you can get a better understanding of how it makes its predictions. Use visualization tools to understand how the neural network works. There are a number of visualization tools that can be used to understand how neural networks work. These tools can help you to see how the neural network learns and how it makes its predictions. Use statistical methods to evaluate the performance of the neural network. There are a number of statistical methods that can be used to evaluate the performance of neural networks. These methods can help you to determine how well the neural network is performing and whether it is making accurate predictions. It is important to note that there is no single way to interpret the results of neural networks. The best way to interpret the results will depend on the specific neural network and the problem that it is being used to solve. That's all the time we have for today. I hope you have found this video to be educational. If you like this type of content, be sure to like and subscribe. If you are looking for an AI partner, be sure to check out Turing Solutions.